Welcome to physics class. Good morning everyone. My dear students, today we are going to discuss about another important topic, photon and its properties. Okay. Photon and its properties. What is photon? First of all, what is photon? Basically, photon is the fundamental particle of light. Light or electromagnetic radiation always consists with photon particle. Okay. And according to Planck quantum principle, each photon contains some amount of energy, and this energy equal to E equal h nu. Okay, in this equation h is called Planck constant and nu is frequency. So now we are going to discuss about introduction of photon. In 1905, Einstein's proposed that in 1905 Einstein proposed that light or electromagnetic. In 1905 Einstein proposed a new theory of light. Theory of light is called photon theory. According to this theory, light or electromagnetic wave, light or electromagnetic radiation, magnetic radiation consists with a tiny packet of energy or bundle of energy. Energy is called photon. Okay, so this is our introduction about photon. In 1905 Einstein proposed a new theory of light is called photon theory. According to this theory, light or electromagnetic radiation consists with a tiny packet of energy or bundle of energy is called photon. Now we are going to discuss about basic properties of the photon. Our first properties of photon is, suppose this is our first properties, energy of photon. Energy. The energy of photon is given by E equal h nu. Where E equal energy of photon, nu equal frequency of photon, and h equal Planck constant. So this is our first characteristics of the photon. The energy of photon is given by E equal h nu. In this equation, E is called energy of photon, h is called Planck constant, and nu equal frequency. Basically, this equation tells us, say suppose E equal h nu, when h removed from this equation, then we can write E directly proportional to nu. It means that when the frequency of the photon is increased, then energy of photon also increase, and when frequency of photon is decreased, then energy of photon is decreased. So energy of photon is directly related to frequency of the photon. Okay. Now move on second characteristics of the photon. Momentum of photon. The momentum photon is P equal MC, and also we know that M this is equal to E by C square into C. C and square will cancel to each other, so E by C, and E we can break in terms of H C by lambda into C. Finally we can write H C divided by lambda into 1 by C. C and C cancel to each other, so H by lambda. So this is equal to momentum of the photon. Momentum of the photon. Okay. The momentum of photon, as you know that momentum, the speed the product result of mass and velocity of moving object is called momentum. The momentum of photon is P equal mc. P equal mc, we know that m equal E by C square into C, and C and square will be cancelled to each other, so E by C, and E we can break in terms of Hc by lambda divided by C. C and C will be cancelled, so H, finally we can write P equal H by lambda. So this is the momentum of the photon. Momentum of the photon. This relation tells us, this relation basically tells us P inversely proportional to 1 by lambda. It means that when lambda is increased, then momentum also decrease, and when lambda decrease, then momentum is also increased. So momentum and wavelength inverse related to each other. Okay, so this is the momentum of the photon given where in this equation P equal momentum, H equal Planck constant, and lambda equal wavelength of the photon, and C speed of light in vacuum, Okay. Now third characteristics of photon, mass of photon. Okay, mass of photon. Number 3 properties, mass of photon. There are two types of mass of photon. One is called dynamic mass of photon and rest mass of photon. Okay. First of all, rest mass of photon. Rest mass. The rest mass of photon is always 0. That is, rest mass is denoted by m naught, so m naught equal 0. Okay. By using this formula, we can prove this. By using this formula, m equal m naught under root of 1 minus b square by c square. Okay. After cross multiplication, we can write m naught equal m into 1 minus b square by c square. When the speed of photon, that means c equal b, then we can write from this equation m naught equal m into 1 by 1 minus b square by c square, then b under root of 1 c square by c square, again m into 1 minus 1, so m into 0, so rest mass m naught equal 0. Now we are going to discuss about dynamic mass of the photon. This is number A, rest mass of the photon, and again dynamic mass of the photon. Number B, dynamic mass of photon. Mass of photon from Einstein's mass energy relation, E equal mc square. Okay, E equal mc square. E equal mc square where E equal energy of photon and m mass of particle and c speed of light. Okay, when E equal mc square, then we can write m equal E by c square, and again we know that E equal E we can express in terms of hc by lambda divided by c square. Finally we can write hc by lambda into 1 by c square. Okay, c and square will be cancelled, so c into lambda c, this is equal of mass, dynamic mass of the photon. So the dynamic mass of the photon we can express m equal h divided by lambda into c, where lambda wavelength of photon, where lambda wavelength length of photon. Okay. Number 4 characteristics of photon. Speed of photon. Speed. Since photon is fundamental particle of light, so the speed of photon is equal to speed of light, that is c equal 3 into 10 to the power 8 meter per second. Okay, so this is our number 4 characteristics. Now move on 5th characteristics. Charge of photon. The charge of photon is 0. That means this is chargeless particle. So photon is electrically neutral. Therefore photon is not deflected by electric field and magnetic field. Okay, so this is our number 5 characteristics of the photon. Now say suppose we know that there are 2 types of charge. One is called positive charge and another is called negative charge. Is not it? So suppose this is electric field, this is positive plate, and this is negative plate. An electric field come from positive to negative plate. This is electric field. Okay, when an electron moves through this electric field, then we know that electron is negatively charged particle, so electron particle deflected towards the positive plate. Okay, and when photon moves through the electric field, then photon is positively charged particle, so photon deflected towards the negative plate. And in this situation, due to electric field, the force act on this electron is F equal minus QE, and the force act on positive charge, this is equal to plus QE. Okay. Again, when photon particle moves in this electric field, then this is stately directly past one side to another side. That means photon is neither deflected from the positive plate nor deflected from the negative plate. Okay, so it means that photon is not deflected by electric field and magnetic field. Okay, now move on next characteristics of the photon particle. Another example, say this is a magnetic field line. This is north pole and this is south pole. When a charge particle, any charge particle, either positive or negative charge particle, passing through a magnetic field, at that time, in this situation, the force act on the positive or negative charge, this is Q equal F equal Q BB sin theta. This is Lorentz force. But in the case of photon, this is not possible. This is not possible. Photon directly passed through the magnetic field. Okay, so we can say that photon is not deflected by electric field and magnetic field. Okay, now we are going to discuss about number 5 characteristics of the photon. Photon travels always straight line. Number 6, the energy of photon is directly proportional to its frequency, that is energy is directly proportional to nu. Okay. Number 7, the energy of photon is inversely proportional to its wavelength. Proportional to its wavelength. It means that is E inversely proportional to 1 by lambda. Okay. Next characteristics, the spin of photon is number 8. Number 8 characteristics of the photon, the spin of photon is 1. And characteristics 9, photon has no antiparticle. Photon can be destroyed. Number 10, photon can be destroyed or created when radiation absorbed or emitted. So these are the basic characteristics of the photon. Okay, thank you.